how refraction takes place through a parallel multiple media. Is that what we are going to study now? If a ray of light is incident on a surface of water, here the first medium is air, the second medium is water, and the third medium is glass. How light travels when it passes through these three different medias? What is going to happen? How it is going to travel? Is that what we are going to study now? At this point, there is separation of media. This side is air and this side is water. At that point, we have to draw a normal. Normal is a perpendicular line drawn to a surface. We have drawn this. This is angle of incidency. We will mark it I1. This ray is supposed to go in this direction. In the absence of these two mediums. Now, this ray will bend and goes. When it goes in water, it travels with the same velocity. It will bend towards the normal because this is air is rarer medium and this is denser medium. It will bend towards the normal. And this is refracted ray in water. Now this angle we will consider it to be R1. This is angle of incidency I1. This is angle of refraction at the first interface R1. Now this ray will meet on another surface, that is the surface of the glass slab. At this surface again there is change in medium. There is change in medium. This side is water and this side is glass. At this surface we have to draw one more normal. We have to draw one more normal here at this surface. Now these two are parallel lines, we have to remember. This is also a perpendicular line to the surface. This is also a perpendicular line to the surface. If this is R1, this angle also will be R1. We have to remember. Because if these are two parallel lines, if they are cut by another straight line, this angle and this angle are called opposite angles and they are always equal. Opposite angles are always equal. This angle and this angle are opposite angles. These are two parallel lines according to the properties of the parallel lines. And if a straight line is cutting these two parallel lines, opposite angles are always equal. Now this is R1 and therefore this will be also R1. Now if you see, this ray is supposed to go in this direction like this. But what will happen is, it is going from rarer medium to denser medium. Again, water is rarer compared to glass. Therefore, again it will bend. Again it will bend. Actually, it is supposed to go in this dotted line like this. But it will bend because it is traveling from water, rarer medium to denser medium glass. At this point again, there is change. If this is R1, we have to call this R2. R2. This is the ray, refracted ray in the glass. At this surface we have change in velocity of light, therefore we have to draw one more normal passing through that point. Now if you see, these three are parallel lines, all are perpendicular lines drawn to the surface of the water. Now if this is R2, this also will be R2. Now this ray is supposed to go like this, but again here what will happen is, again the light ray is coming back to air, again it will bend away from the normal. Here also it is undergoing displacement, lateral displacement. When it is going from air to, again it is coming back to air. This is, we will call this one to be E emergent. Now you see, this is a normal. This is also a normal. Therefore, what happens here is, if you see, this E becomes I1. These two angles are equal. Now if you see, if you write Snell's law here at the first interface, okay, if Snell's law at the first interface of according to Snell's law, when light is traveling from air to water, that is equal to sine I1 by sine R1, sine I1 by sine R1. That is Snell's law at this interface, at Snell's interface at first refraction, when refraction is taking place in the beginning. We will consider this equation to be 1. Now again, due to refraction at the first interface, this one. Now according to due to the refraction at the second interface, now what we have to write is light is traveling from water to glass, that is equal to R1, here R2, sine R1, here this is the angle of incidency for this interface, R1 by sine R2 at the second interface. This is Snell's law at first interface. Now if you see, we will consider this equation to be true. Now at the third interface, here what we have to write is light is traveling from glass to air again, that is equal to sine, this angle is R2, angle of incidency there is R2 by sine, this angle is E, that can be equal to I1. This is third equation. If you multiply all these equations, left hand sides and right hands, multiplying 1, 2 and 3 equations, we get all left hand sides mu A to W into mu W to G into mu G to A. This is equal to sine I1 by sine R1 into sine R1 by sine R2 into sine R2 by sine I1. Sine I1 and sine I1 gets cancelled. R1 and R2 gets cancelled. R1 and R2 gets cancelled. Therefore, we get mu A to W into mu W to G into mu G to A will be equal to 1. This is the significance of refraction through parallel multiple media.